In this example, we have a baseball player catching a baseball. The mass of the ball is 145.0 grams. Its speed is 22.1 meters per second. And the baseball player is applying a force of 55 newtons in order to stop the ball. The question is, how long will it take for the ball to come to a stop? Well, the baseball's momentum has clearly changed. Before the baseball player caught it, it had a momentum because it had a speed. However, the baseball player is going to catch it and stop it. At that point, its momentum is zero. So the momentum has changed. We need to calculate that change in momentum. Well, let's calculate the initial momentum, mass times velocity. The mass is 0.1450 kilograms. We have to convert from grams to kilograms to keep the units SI. I assume you know how to do that. Then we multiply by velocity, 22.1 meters per second, to get an initial momentum of 3.20 kilogram meters per second. Now, in order to use equation 9.6 to figure out the time, I'm going to have to figure out the change in momentum. Well, the initial momentum was 3.20 kilogram meters per second. The final momentum was 0. So the change in momentum, final minus initial, is negative 3.20 kilogram meters per second. Now I'm going to do something that really annoys students. I'm going to drop that negative and say that delta P is just 3.20 kilogram meters per second. How can I do that? Well, I'm solving for time. Time is a scalar. It has no direction. So I don't need to mess with direction in this problem. I could define motion the opposite way of the ball as negative. That would make the force negative, and that would allow the negatives to drop out. So if you want to do that, that's fine. But since I'm solving for a scalar, I don't need that negative. I don't need direction. So I'm just going to drop it and say that delta P is 3.20 kilogram meter per second. So with that in mind, force is 55 newtons, delta P is 3.20 kilogram meters per second, and delta T is what we're trying to figure out. We solve for delta T by multiplying both sides of the equation by delta T and then dividing by 55 newtons. And if I replace newtons with the proper definition, kilogram meter per second squared, you'll see that the kilograms cancel and one of the seconds cancel. Finally, the meters cancel as well, and I'm left with a unit of seconds, which is good because I'm solving for time. And the numbers work out to 0.058. So it takes the baseball player 0.058 seconds in order to stop the ball.